All right, today we will be working on a lesson where we're going to build a bridge. I know you guys have been in geometry and you guys have worked on right angles, equilateral angles. We're going to put all of that information you have and we're going to put it into the idea of building a bridge. I'm going to show you guys a couple bridges that I think are very important to our society and what your guys' bridges should try and imitate.
Cue slideshow.
Yeah, cue slideshow. We'd show, so Dr. Michaels, we would show him the slideshow. We'd show him what kind of bridges there are in America. We would probably ask questions like, does anybody know any type of bridges that are very popular and that you know of? So we let them answer that question. What do you want to say? Anything?
And
else?
then I just think that, and then we would also, like ask them questions like, does anybody remember what a right triangle is? What makes up an equilateral triangle? That way we can make sure that they do still remember those concepts since they're going to be using them when they build their bridges.
All right, and to start out building the bridge, you will get you'll get here we go. You will get $7,000. So we will give each group $7,000. So we'd go around to each group. We'd split each group up in threes, like our classroom. We had three groups of three, and for each group we'd give everyone the role of. So one would be the tester, right?
One would be a tester, one would be the planner, and then one would be like the money person in charge of a lot, like rationalizing their money.
So we would give them each role so they know what's expected of them and what they have to do for that lesson. We don't want to give them. We don't want just to throw it at them and have them just try and guess of what they do. So that gives them a role of what they actually need to do. So they get $7,000, and everyone's looking. But you get $7,000, and each material that they want to use to build their bridge will cost money. So, for example, a ruler. If we had a ruler, it'd be for one of them, it'd be $200. Let's say for the popsicle sticks, for every 10 sticks, it would be $200. And so for a yarn, the 3 inches would be $100. And then the duct tape, 1 foot, would be $250. 1 foot of masking tape would be $200. The cars that we set out, we give them each group 3 sets of cars. Most of them are different size, we hope so we can differentiate. And we're going to give them out for free. The Scotch tape will be 1 foot will be $100. So the stronger the tape, the more expensive. So we make the students think like what choices they need to make and how their bridge is going to be different from other groups.
And we would also make sure that they know that any material that they want to use, if they want to, in order to get maybe extra credit, they can use a material for decoration. Like maybe they don't want to use yarn actually for support, but they want to use it to make sure that they're decorating their bridge or they're making it look like a suspension bridge. Maybe you're trying to do something cool with it that way. And then that way we're getting to see the students' creativity too, not just, oh, we're trying to meet these, these considerations that we have to meet just to pass. We want them to be able to extend their thinking too.
And then I would explain to the class like the rules as to which we're going to give them. So each group must have, their bridge must be 18 to 22 inches. So the popsicle sticks are about, you said 5.9?
They're about 5.9 inches long, each stick.
So we give, if they bought a ruler, then they could use that ruler to see how long their bridge is and just to basically get all the rules we're giving them so that make sure they get that right.
And if they choose not to buy a ruler, they can also use that rounding of the popsicle stick being about 6 inches and saying that about 3 of the popsicle sticks was the minimum length for the bridge. And it just gives them a rough idea. That way if they choose to spend their money on materials instead of on the measuring, then they can just, go ahead and measure it that way. And then that's making them use the critical thinking skills of using the length of the stick as a measuring tool instead of having to use a traditional ruler.
So for all the materials, we're just trying to differentiate the price so it makes them think like how they want to spend their money. So that can be a science and a math example on one. For math, I got to think about how much money I have and how much the materials are.
Budgeting skills.
Yeah, the budgeting skills. And for science, I mean, it's already we see bridges everywhere. It's an important thing for us to live. So we can get over water. What else can it do?
We can navigate terrain. We can increase the roadways, like how the freeways go over each other. It just helps when you have a highly populated area to be able to build bridges.
And we could also maybe if we had more time, go into more depth to show them popular bridges around, and then just show them how it was built, what materials were used, just kind of just to show the materials they're using, kind of exemplifies what happened in the real world. So we would give them, what do you say, 10 to 15 minutes?
I would say even between 10 and 20 minutes,
10 to
just
20
because
minutes.
it will take them a certain amount of time just to come up to the teacher's store and buy their materials and figure out what they want to do, and then they have to have time to work together to plan what they're going to do and then actually execute the design. I built a demo bridge and it took me about 10 minutes, so I would say just giving them that 20 minutes will give them enough time to actually plan and then execute the bridge.
And she only used, if you look here, 2 materials, and she got the desired results as we wanted. This is 18 and 22 inches, and she also made a right triangle on the back. If you can see it right there. She made about 3 right triangles, but she showed us where the right triangle was, and it's 18 to 22 inches. And the only material she used were the sticks and the masking tape. So she only had. Do you think it was 1 foot? Or do you think it was 1 more?
I would say it's about 18. I think it's about 18 inches long.
Okay, so and she maybe spent about. What I'd say. You know how many sticks did you use?
I don't know how many sticks.
Let's count. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20. All right, let's say it's 30. No,
yeah, probably about 30. I'd probably say about 30 sticks because you have to buy them in quantities of 10. So that'd be about $600. Plus, I used. I would say I used probably about 6 feet of masking tape total. So that'd be another $1,200. So $1,200 plus 600 is $1,800. So I used about $1,800. So the $7,000 we're going to give them should be plenty for them to use more than one material, and perhaps maybe for the advanced group we are requiring them to use at least 3 or 4 different materials. That way, we're getting a more advanced outcome, or we can also give them a smaller allowance. So we're really making them think about how they're going to spend their money. But this is just an example of how we would do it.
And since she didn't spend as much money, she can buy yarn, even more types of glue. We can give them markers too if we had enough time, just to design it and just make it kind of their own bridge.
And maybe the more artistic you make it, like we said, maybe give them extra credit for using that extended thinking and making it, creative versus just meeting the requirements. Which this bridge just meets the requirements. It doesn't exceed the requirements.
Right. And then for the geometry, we use the right triangle, and that's 90 degrees.
Mm-hmm.
But yet we use this. That's the geometry and math part. We're trying to get them really to use. I could even throw in equilateral, which I don't know.
This is like an equilateral triangle because all the sticks are the same length. It
shouldn't be too hard for them to understand geometry, but we're going to both be walking around. Actually, one of us will probably be staying to collect materials and have the students pay, and then one of us will be walking around just to make sure both their groups are doing what they're supposed to be doing, and everyone's partaking in their actual role.
And then after the students have built their bridge, we're in a room that doesn't have 2 tables, but we would be in a room with 2 tables, and one table would be hold your hand up to hold that side. One table will be holding one end, the other table will be holding the other end, and we just put the cars in the middle and make sure the bridge doesn't break. And if the bridge breaks, obviously then the kids have to start over or fix it and make it stronger. But as you can see, my bridge meets the requirements and it holds all 3 cars. And maybe they'll get extra credit if we can put more cars on it and see how many cars their bridge could hold. Just for fun, or maybe we'll just do it for fun at the end. Whoever has the coolest bridge will see how many cars they can hold. It just depends on how much time we would have for the lesson, how creative we would get with it to let the students get with it.
And our student has dyscalculia, right?
Mm-hmm. Yep.
Our student has dyscalculia, and for us, we're going to probably let him use a calculator, and I'm probably going to put him with a group that probably excels more than the other groups would, just to give him help. And with a calculator, it'll probably help him with the materials used. Just kind of giving him not really an advantage, but something that's going to help him out so he can actually participate with the other groups.
And then perhaps we'd also let him use the an app on the iPhone that would show him, there would be a protractor for him to measure the angles more accurately, and maybe we would give him a cheat sheet, like here's what a right angle looks like, here's what an equilateral triangle looks like. That way he can see it visually in his head without having to do the extra thinking, you know, and really stress himself out, you know, thinking way more than anybody else would have to think. That cheat sheet would really give him a little bit of advantage that would put him back on the same level as the other students in the class.
We would probably give, like we said, we'd give them 10 to 20 minutes after we were done. After every group is done, and they're pretty much positive that's the one they want to test. We would test, like she said, with the 3 cars, and then after that, we're going to compare and contrast. We'll have 3 of the bridges up front, comparing and contrasting the bridges and how they were made. We'd have each group explain why they picked the materials they did, and why they did. And we'll just compare and contrast, and we'll probably test every single one of them up front just to give the students a little bit of fun, just to see if they all pass or not. But the biggest thing is comparing and contrasting and having them explain why they did the things they did.
And maybe have them ask each other questions like, why did you decide to use the yarn, or why did you decide to put your right angle here instead, and just get an idea of different other people's thought processes other than your own, because maybe those ideas could benefit you for another lesson that we may do later on in the semester.
And then after that, that would probably conclude our lesson?
I mean, yeah, that would conclude our lesson. Just let them have a discussion, maybe let them have a little bit more fun testing the bridges, and then we put the bridges away and you know, let them move on, do a transition activity to the next lesson. Yeah.
And then after that, we might go more in depth into geometry and more depth into just how things in the real world are made, just to make the connection from the classroom to the real world, because students are always asking, why do we got to do this and why we got to do that? When in fact, there's a lot of times when everything you do in school relates to something outside.
We may even be able to bring, possibly like right around what time we do this lesson, bring like an architect in, or somebody who builds bridges for life, for, you know, a real life job, and have him explain to the kids how some of the things that they had to think about in their mini lesson was some of the stuff he has to think about on a much bigger scale in real life. And then that would give them the fact of knowing that I would actually use this skill in a real job. It's not just something I had to memorize for school. It's something I would actually use later on in life.
And then after that, that would probably conclude our lesson.
Yep.
Good?
Yep.
Sounds good, Dr. Michaels.